All right, let's get right into it. Today, we are going to unlock a new superpower for your computer. Seriously, we're talking about taking back control, automating all that boring stuff, and really making your machine work for you. We're talking about shell scripting. You know the feeling, right? If you've ever used a command line terminal, you've been there. You type a command, then another, and an hour later, you're typing that exact same sequence all over again. It's tedious, it's repetitive, and honestly, there's a much, much better way. And that better way is, you guessed it, shell scripting. This is the solution to all that repetition. It's your own personal automation superpower, and you'll be surprised at how easy it is to get started. So what is a shell script, really? Well, at its heart, it's just a simple text file. That's it. But inside that file, you write down a list of commands, a sequence of steps. Then, when you tell the computer to run it, the shell just reads your list and carries out those commands, one by one, all on its own. The best way to think about it is like a recipe for your computer. You write the instructions once, and it can follow them perfectly, every single time. Okay, enough talk. The best way to learn this stuff is to just do it. So let's get our hands dirty and write our very first script. We're going to start with the classic, hello world. It's kind of like a rite of passage in programming, and we'll do it in 5 super simple steps. So here's the game plan. First, we use the touch command to create an empty file. We'll call it hello.sh. That .sh at the end just tells us, hey, this is a shell script. Second, we open that file in a text editor. Something simple like nano is perfect. Third, we add our 2 lines of code. We'll talk about what they mean in a second. Fourth, and this is a really important step, we have to make the file accessible using chmod + x. This basically gives the file permission to run as a program. And finally, step 5, we run it. You type /hello.sh, hit enter, and boom, you've just run your first script. Let's quickly look at those 2 magic parts. That very first line, the one that starts with a hash and an exclamation mark, that's called a shebang. It's a special instruction that tells the operating system which program it should use to interpret the file. In this case, we're saying, hey, use the bash shell to run this. And chmod + x, think of it like a magic word that turns a boring old text file into an actual runnable program. It grants it the power to execute. Awesome, you've run your first script. Now let's take it to the next level. Let's start giving our scripts a bit of a brain. This is where we learn how to store information and even get input from a user, making our scripts way more dynamic. First things first, variables. These are just little containers where we can store pieces of information, like a name or a number. But listen up, because there is one huge rule that trips up almost every single beginner. When you assign a value to a variable, like name equals Unix, there can be absolutely no spaces around the equal sign. Name equals Unix with the spaces will just give you an error. You have to remember this. No spaces around the equal sign. Okay, but what if your script needs information you don't have yet? Well, you can just ask the user for it. It's super easy. First, you use the echo command to display a message, a prompt, like enter your name. Then, you use the read command followed by a variable name. The script will literally pause and wait for the user to type something in. Whatever they type gets stored right into that name variable. Just like that, your script is interactive. All right, now we get to the really powerful stuff. This is how we make a script truly smart. We're going to give it the ability to make its own decisions and to repeat actions over and over again. We are talking about conditionals and loops. So, for a script to make a decision, it needs to compare things. Is this number equal to that one? Is it bigger? For that, we use these special conditional operators. Now, they might look a little weird. Instead of the usual math symbols, shell scripting uses these short letter codes. EQ for equal, NE for not equal, GT for greater than, and LT for less than. These are the tools that let you build real logic into your scripts. Right, making one single decision is great, but what if you need to check 100 different things? Or do the same task 500 times? You're not going to write 500 separate if statements. You need a way to do things on repeat. And that's where loops come in. You've basically got 2 main flavors. The for loop is your go-to when you know exactly how many times you want to do something, like counting from 1 to 5. But then you have the while loop. It's a bit different. It just keeps on going as long as a certain condition stays true. This one's perfect for when you don't know ahead of time when you'll need to stop. Okay, this is the hero moment. We've learned about variables, user input, making decisions, and repeating actions.
Now, let's put all those pieces together and build something genuinely useful, a program that can check if a number is a prime number.
So, step 1, we need a number to check. We'll ask the user to enter 1, and we'll store it. Then we create a variable that we'll call a flag. Just think of it like a little light switch that we'll set to 0. We're going to assume the number is prime to start, and our goal is to try and prove ourselves wrong. Next up is the loop that does all the heavy lifting. Now here's a little trick. To see if a number has any factors, we don't need to check every single number up to it. We only need to check up to half of that number. So we'll set up a for loop that starts at 2 and counts up 1 by 1 all the way to our number divided by 2. Inside this loop is the most important part. We use an if statement with the modulo operator. That's the %sign. All it does is give you the remainder of a division. So if n divided by I has a remainder of 0, that means it divides perfectly. We found a factor. If that happens, we immediately flip our flag's value to 1, and then we use the break command to just exit the loop right away. There's no point in checking anymore, right? We already know it's not prime. And that brings us to the grand finale. After the loop is finished, we just need to check the status of our flag. If the flag is still 0, if we never managed to flip it, it means we never found a factor, so the number must be prime. But if the flag got flipped to 1, we know it's not prime. And boom, we just built a real working program from scratch. Now, this wasn't just some fun little exercise. Learning shell scripting is a truly foundational skill. It's something that has massive real-world value, from your university computer science lab all the way to a 6-figure career. I mean, just look at the hottest fields in tech right now. DevOps, cloud engineering, system administration. Shell scripting is an absolutely non-negotiable skill for all of them. It's how modern software gets deployed, how servers get managed, how entire companies automate their infrastructure. And yeah, for all you students watching, this is core curriculum stuff. Mastering this is how you're going to ace those practicals and Viva exams. This quote really hits the nail on the head. It's not just about making a few tasks go faster. It's about learning to speak the language of your operating system. When you master this, you build a powerful foundation that makes you a better developer, a better engineer, and just a more productive person at the command line. So I'll leave you with this question to think about. What's something you do on your computer all the time? What are those commands you find yourself typing over and over and over again? Now that you have the building blocks, what's the very first tedious task you're going to automate?